Hello, everyone. In this video, I will be going over the ISAT model within the APIM framework in lavaan using R. So if you have not watched other videos on the actor-partner interdependence model, watching those first might be helpful. I will be going over the basic APIM very briefly and then situating that within the context of the ISAT model. So the first thing that we might want to review is what is the actor-partner interdependence model. That is a model where we have nested data, and generally it's going to be dyadic, but we can also have triadic data, or we can have quads. There's a lot of flexibility within the APIM, and it really estimates how my independent variable predicts my dependent variable, and how my independent variable predicts my partner's dependent variable, and vice versa, where they affect their own, my partner affects their own outcomes, and they affect my outcomes. And so this is a way that we account for that nesting, for the non-independence of data. Because if we were just to analyze this using regular old ordinarily squares or structural equation modeling with maximum likelihood, we would have correlated residuals, which essentially means if you know a little bit of something about how I communicate in my relationship, you're actually going to know a little bit about how my partner communicates in that very same relationship. And again, that's a correlated residual, which leads to substantial bias in your standard errors and your test statistics. So essentially, the model believes you actually have more unique information than you actually do, and as a result, your standard errors are going to be too low, which means your test statistic is going to be too high, which means your p-values are going to be too high, and you are at a strong likelihood for running into a type 1 error. And so we need to account for that non-independence. For if you know something about my residual, then you know something about my partner's residual. And within the APIM framework, we do that by partner effects and by correlated residuals. And so within the ISAT model, more specifically, what we're going to do is we are going to constrain all of the effects within the model to be equal across partners. And so what we're going to do is we're going to constrain all of the means, the variances, and the covariances of our parameters to be equal across partners. So essentially, the actor effect for myself is going to be identical to my partner's actor effect. And so the influence I have on my partner, which is the first partner effect, is going to be constrained to equality with my partner and how they influence my outcome, or that's the second partner effect. We're also going to constrain the means and the intercepts on our dependent and independent variables to equality. And we're also going to constrain our variances to equality. And so what this does is it provides a test of distinguishability. I have a theoretical rationale for why I'm analyzing why I'm using gender as a distinguishing variable. I believe there's gender socialization processes. Men and women experience relationships in a lot of the same ways, but also there's going to be unique aspects to both. Depression, for example, is more common in women than men. And so I have a lot of reasons to really believe that gender could be an important factor to consider. And so I have a theoretical rationale for that, but what I want to do next is I want to empirically test whether or not that theoretical rationale is supported by my data. Because it could be, I believe that men and women are different in communication processes, which will be our RMM variable, and depressive symptoms. It could be that the means, the variances, and the covariances are identical. In which case that hypothesis would not be supported, and I could actually proceed to analyze them, keeping all those constraints that we're going to implement in place. And so one of the benefits of that is if you have gay or lesbian couples in our example, and we find out that our heterosexual folks are indistinguishable, that the ISAT model, by constraining all of those parameters to equality across groups. That means assignment is arbitrary to partner one and partner two, and gender doesn't do a very good job at distinguishing them, which means we can pull in the gay couples and we can pull in the lesbian couples, and we can actually increase our generalizability if that ISAT test is non-significant. Right? If there is no harm caused to our model by constraining all of those parameters to be equal. Another time in which you would use the ISAT model is going to be when you have indistinguishable dyads, which could be kind of same-sex twins, for example, where you don't have a theoretical rationale for distinguishing, twin one from twin two, especially those monozygotic twins. Right. And so assignment is going to be random and arbitrary. And so by implementing the ISAT model and constraining all of those paths to be equal, that will confirm our hypothesis. If our ISAT model is significant when we have theoretically indistinguishable dyads and there is harm caused to the model, then we have to think about why would twin one have a higher actor effect than twin two. It might be due to sampling, it might be due to measurement or data coding or whatever it is, but that should be non-significant, all right? Because we're believing they're identical. So everything about them is the same. So those are kind of the tests or the rationales for why we would use the ISAT test. So essentially it's to confirm indistinguishability among indistinguishable dyads, and potentially to confirm or disconfirm distinguishability across dyads that we believe can be distinguished by a variable within our data set. And we are going to distinguish them across gender in this analysis. And so another thing I will say before getting started into the analysis is that there are other implications beyond theoretical for distinguishability. What simulation research has shown, Lederman and colleagues published a 2022 article in Family Relations looking at power within the APIM, I believe is a mediational model. And you actually need a fewer number of dyads to achieve the same effect size if your dyads are indistinguishable. So, and I believe the estimates were around 125 dyads is kind of the minimum that they kind of highlighted and recommended. But if we've had indistinguishable dyads, we'd only need, I believe it's like in the perhaps in the 70s or in the 80s. So you need 30% less in terms of sample size, which of course, budgeting wise, you spend way less money in participant compensation. So there are important practical and statistical implications for distinguishability. So what we're going to do first is, this is the same APIM that I have shown in other videos, where we're going to use male and female depression to predict male and female relationship mindfulness. And so what you are going to see here is this is just the basic actor-partner interdependence model. There is nothing special about it. In this model, I haven't imposed any of the constraints that I'm going to impose in the next model. Rather, I am setting this model up so that I can conduct a likelihood ratio difference test in order to compare the two models. And so what you will see here is we have relationship mindfulness for males being predicted by depression for males with the _M, and females, and female relationship mindfulness being, I guess I shouldn't say predicted, being covaried with the two tildes, with male depression and female depression. You can use just a single tilde in this. You will actually get the exact same value. You'll get the exact same results. Your CFI and your TLI could potentially be different, but your negative 2 log likelihood value will be identical, as will your chi-square statistic, which is really what we're going to be looking at here. By using regression with only a single tilde, your variances on relationship mindfulness become residual variances. Again, it won't necessarily affect the model fit. These will be perfectly equivalent models statistically. You will not be able to differentiate them. But in remaining within the kind of the truest sense of the ISAT model, I'm going to keep them as covariances. And so what we're going to do is we can go ahead and we can run this model. Again, it will be saturated. It will have 0 degrees of freedom. And if it doesn't, then there's a potential syntax error. All right, so again, we can just take a look. I'm not really all that interested in the result at this point. I just want to estimate it. I want to be sure that I've estimated it correctly, and that we have our 0 degrees of freedom, and we do. All right, so now we can move down here into the second part where the syntax gets a little bit denser. And so what you will see here is I have installed value labels on all of the parameters in this model. All right, so we'll start off with these covariances up here. And these are going to be the covariances, or what would have been actor and partner effects. And so you'll see I have male relationship mindfulness covaried with CESD for men and CESD for women, and I've attached labels. So A1 and P2 represent, again, the first actor effect or the second partner effect. These labels are incredibly arbitrary. I have estimated the ISAT model both ways using both regression and just simple covariances. And so I just chose the label A1 and P2 in order to keep with how I estimated using or transforming the relationship mindfulness residuals from variances to residual variances. All right. So again, incredibly arbitrary. It's whatever really works for you. I like actor and partner because that's what makes sense to me. And you will see that that we also have these covariances between your IV and your DV. Those you do not touch in the ISAT model. Okay, so there's nothing to really constrain those effects to, because it doesn't make much sense to constrain the effects or the covariance between men and women's reports of relationship mindfulness to be the same as the covariance between depressive symptoms between partners. There could be a lot of theoretical reasons why that's just not a tenable assumption. And it's really testing the association or the covariance between two variables, which again may very well be different. So that doesn't really give you a whole lot of information, right? And so down here, we are constraining the means to be, or the intercepts to be equal. All right, and so what you'll see is I'll actually be modifying this code. I'm just going to walk you through it real quickly, and then I will go in and I'm going to actually do the constraining, because as of right now, it is not fully constrained. Or there's actually a second way to constrain the code and the syntax. And lastly, we are doing constraining the variances, or perhaps if you're doing it the traditional way, we're using regression coefficients instead of covariances. You're constraining residual variances of relationship mindfulness to be equal across partner, and we are constraining the variances of depressive symptoms to be equal across partners. All right, so again, there's several different ways to constrain variables. The way I have found to be easiest, this differs a little bit from how I would do things in M+, but this is one of the idiosyncratic natures of lavaan, is that you could I just constrain them to be equal using these equality constraints, where I had to constrain A1 and A2, those two actor effects, to be equal. I constrain P1 to P2, those partner effects to be equal. I2, I1 to I2 for intercept. That's what led me to say I1 and I2. And then CESD, I3 and I4. If you want to get technical, you can differentiate between means and intercepts. But for the purpose of this, it doesn't really matter. And then we constrain the variances or the residual variances to be equal across groups. All right. And we constrain the variances of depressive symptoms to be equal across groups. All right. So I found that this is the easiest way in lavaan. There are alternative ways, but this is my preferred method and what I'm going to be showing you all. And so down here, we have everything is exactly the same as up top. So we have the mean structure. We're referencing our data, our model, our data, our mean structure equals true, missing equals ML. That's so lavaan doesn't do list-wise deletion. We are employing full information maximum likelihood, so we don't lose those cases where they are missing data points. And then we have our typical SEM summary. The one change that you will see that you probably notice that's different from other videos is that R squared equals F. Since technically I am using the covariance method, all of the variables are considered independent variables, and so there's not any regression coefficients. There's not variance being predicted. Therefore, we cannot calculate in R squared. And so we will turn R squared off. You can actually turn R squared on. You can turn that to T, and then you'll just get an error message from lavaan saying there are no dependent variables. So I can actually show you what that looks like. So mod indices here, this is actually becomes important up top. You will see I have it, but it's a saturated model, so it's not of importance. But down here, this will be helpful because it can potentially point us in the direction of which parameters in our model are not are moderated by gender. So essentially, that's another way of thinking about the ISAT model, is thinking about parameter moderation, and that includes means, variances, and covariances. And we're testing them all at once. Right? And then this last line of code is the likelihood ratio test, comparing the fit from model 1 to model 2. So we can go ahead and we can run this. All right, so here is that R squared warning message that I said that we would get. All right, so we can kind of scroll all the way up to the top. So we have 305 observations, which is good because that's how many people in our data sets. We have 0 degrees of freedom. So again, we're good there. And again, we're not really worried about parameter estimates and things of that nature. We're not necessarily worried about mod indices, especially in that first model. And so we'll scroll down to the ISAT model where we have those equality constraints imposed. All right, so in the ISAT model, you should have 6 equality constraints, right? So the means of the IVs should be the same. The means the DVs should be the same. The actor effect should be the same. The partner effect should be the same. And the variances of the IV and the DV should all be the same. So if you add all those up, that's going to be 6 degrees of freedom in our model. And so we have that here. So we have total number of 14 parameters, which is correct. And then we have those 6 equality constraints. And so here, what we see is that by imposing these 6 equality constraints, the model is significantly harmed by those constraints, which means we can say that there is moderation that is happening here. You will very rarely see the ISAT model talked about in empirical articles in the context of moderation, but essentially that is really what we're testing here. And again, we're testing an omnibus test, so we don't actually know what parameters are being moderated by gender. We might be able to take a theoretical guess, but we'd have to actually go in and gradually release these constraints and test them one at a time in order to determine which paths are actually being moderated by gender. But this tells us that constraining everything to be equal does harm to our model, and therefore we will need to release the appropriate constraints. All right, so again, we have CFI, we have TLI, we have RMSEA, we have our findings. Again, generally, I don't find much value in interpreting substantive findings within the context of the ISAT model, because essentially what we're really trying to do is just evaluate model data fit and conduct those likelihood ratio tests. All right, and so we see down here our chi-square difference tests, which is a specific version of a likelihood ratio test. And we see that are the same parameters that we got up above. So these 6 degrees of freedom with 20.908, 6 degrees of freedom and 20.907. So you have a minor rounding error, but you'll get the exact same test. And we know it is significant at the 0.001 level. All right, so in principle, that is the ISAT test for the basic APIM. And the beauty of the ISAT test is this can be scaled up to the actor-partner interdependence mediational model, where you just add in the parameter constraints for that mediating variable, for that third variable that you were introducing. Then you constrain all those variances to be equal, the covariances to be equal. And again, it scales up. You can also move this into the cross-lag panel model version of the APIM with repeated measures. You can do a lot of really great things. So hopefully this was helpful in helping you identify and estimate the ISAT model within lavaan.